Hi, guys. Thank you so much for being here today. It's lovely to see familiar faces. I'm going to start with a brief introduction for all of you, and then we'll get right into it. Um, okay, so this panel will be discussing climate drivers and impacts. What is climate change? How does it impact our lives, like right now, and how will it continue to impact our lives in the future? In often kind of invisible or under-discussed ways. So our panelists here today, we're honored to have such distinguished experts with us. We have Dr. Andrew Dessler, who's a climate scientist and professor at Texas A&M and the director of the Texas Center for Extreme Weather. We have Dr. Josh DeVincenzo, who's an assistant professor at Columbia University and assistant director for the National Center for Disaster Preparedness, also one of my former professors. And we have Melina who is an agriculture and climate reporter for the Associated Press. She's written extensively about climate's impacts on farmers and how they've adapted to it, and also one of my good friends from my time at the Arizona Republic. Okay, thank you guys so much for being here. I was wondering if we could start by, could you give us a very brief description of climate change? What is it exactly? What are some of the impacts that we can expect to see here in Dallas-Fort Worth, Texas, and the world as a whole?
Is that for anybody in particular, or do you want
Anyone's
to?
free to answer, but Dr. Dessler, I think you have a lot of expertise here. So
Right. So when we talk about climate change, what we mean is changes in the average conditions. So, weather is what we experience day to day. And if you average that over a decade, you get the climate. And climate change means this shift in the average conditions. And sort of by definition, if the average conditions shift, the underlying conditions have to shift, which means the weather is changing also. The most direct impact of climate change is temperatures are going up. That means extreme temperatures are going up. But there are also these knock-on effects, things like precipitation patterns are changing. We now tend to get more intense rain events. When it does rain, it rains harder, and then you have longer periods without rain. We also see sea level going up. And then there are all of these sort of what I would call second order effects that then follow on from then, things like hurricanes becoming more damaging, droughts, floods, all those other things which fall directly from these other things. Now, one of the things that's important to understand is climate change is never the cause of a big hurricane. The way to think about climate change is like steroids for the weather. It takes a hurricane, which may have been serious, and it adds 20% to it, to whatever metric you're interested in, and that can push it past thresholds that your infrastructure can handle. So you can go from no damage to a lot of damage because of climate change. In much the same way that steroids can take a baseball player who hits warning track fly balls, adds 15 feet to it, and now it's a home run. And that's essentially the way to think about climate change.
I can jump in real quick and just add that, like, for us as journalists, one of the things we have to think about a lot is communicating that it is human caused and thinking about the root cause being our emissions of greenhouse gases into the atmosphere. And Dr. Dessler, please jump in if I get anything wrong as I'm speaking off the cuff here. But one of the things that can be hard sometimes is people, think like, oh, is this something that the climate's always been changing. We had ice ages and this and that, and there's plenty of science that goes into understanding the specific human caused impacts, and I just think it's really important for us to communicate about that too.
Yeah, just to kind of tie in both of these ideas here, I think it's such a great question. Coming from more of the behavioral science side, we just had three different answers. And I'm going to add a third different kind of answer of what it is. So we have kind of the scientific perspective, the journalism perspective, and on the behavior side, that's something that we're always balancing as well. It's if you ask someone what do they think climate change is we're going to kind of default to what we know, kind of our reference points, and that will be our definitions. But we carry with the general public all these definitions of climate change that may vary, and to the communications challenges, that becomes a really important one. So from my vantage point, what Dr. Dessler mentioned around the secondary effects of disasters, I'm looking at the definition of climate change from risk, and kind of the steroid analogy in translating into risk for us is the risk multiplier of climate. So what's at risk? People put in harm's way that are at higher levels of risk. How does that risk change over time for these types of extreme weather events? And all of that is part of this larger system of climate change definitions and discussions. But what also makes it so important that we are looking at all these different perspectives together, the scientific, the journalistic, and then just kind of the everyday person's experience. And that's one thing that we've seen is it's going to be the technical definition, the policy definitions, plus how people are observing and visualizing and going through this in their day-to-day lives.
These are all excellent answers. And thank you again, Dr. Dessler, for pointing out how, maybe a hurricane isn't caused by climate change, but it makes it 20% worse. And we've carefully engineered and designed our infrastructure and other systems to withstand like certain temperatures or certain levels of variability that climate change is now disrupting. And I think that's a really excellent way to think of climate change as a disruptor and a risk multiplier. Moving on to our next question, which is kind of an excellent bridge. So we've seen fluctuating weather, particularly at the beginning of this year in Dallas-Fort Worth. 1 week it was snowing, the next week it was literally 70 degrees. We've also seen record-breaking extreme heat. Was this climate change?
Do you want me to answer that?
Yes, please.
Well, yeah, I mean, so what you experience in your day-to-day life is weather, and particularly in Texas in the winter. On average, it's not that cold, but then we have these cold events come through, and so you're always getting these really big changes. That's not climate change. That's just the weather. To what the impact of climate change really is that it kind of shifts the baseline a little bit. So for most days, it doesn't have a very big impact. If it's 60 degrees outside and it would have been 56 degrees Fahrenheit, it's not a big deal. When it really begins to matter, though, is when you start getting to the summer and you start getting these high temperatures. To the Gulf Coast of Texas is about 5 degrees Fahrenheit hotter now than it was in the 70s when I was growing up in Houston. And so that means that a day that was 97 in the 70s is now 102. And that's a big difference. And that's really the big difference. It's also making all your precipitation events a little heavier. And again, for most precipitation events, it doesn't really matter. But then you have Hurricane Harvey. You have these 1 in 1,000-year events, and those are much worse because they push us again past all the thresholds that we've designed into our system. So climate change, again, it's this thing that's adding to everything that's going on all the time. I mean, no event in the atmosphere is unconnected to climate change, but there's also a lot of stuff which is, there's a lot of variability in the system that goes on naturally, and the main impact of climate change just makes everything a little bit worse, and then you have to deal with it when it pushes past thresholds.
I can real quick just say that from the journalist communication perspective, something about extreme weather is that it is really a learning opportunity for people, because it is one of those moments when people are actually paying attention and they're kind of plugged into it. And so I think it's really great that attribution science is getting better, where scientists can more quickly tell us what was the kind of additional 20% that went into XYZ hurricane or wildfire or whatever it is. But it is a tough job for us as journalists to be very careful when we're reporting in the immediate aftermath, because we know that scientists are immediately going to start working on to what extent was this event made worse by climate change. But yeah, it's also that's when people are paying attention, because people's homes are burning down or people's homes are getting flooded or destroyed. So just wanted to throw that in as well.
Yes, definitely. So if we can move on to a somewhat related question. And you know, I think there's also like a tendency within some circles to say everything is climate change. There's any like wildfire, it's climate change. Any like extreme event is climate change. When again, as we've discussed, climate change is a risk multiplier. It affects everything, but it's just making existing issues a little bit worse.
Yeah, I mean, I would let me interrupt. I think that whether something's climate change or not is not the right question. You know, at some level, everything, you know, climate change affects everything. And so the question of did climate change have effect is actually not interesting. The interesting question is how big of an effect did climate change have? And I think in a lot of cases, it's not a big effect. In other cases, it is a big effect. And I think that's really the question. So I think we need to get rid of this idea of did climate change cause this and instead start asking how much did climate change change it?
I think that's a really, really important point. And so just transitioning, can we talk about how scientists know exactly how much climate change has affected something? What exactly is climate attribution science? It's being used more and more in courts to determine accountability for different like holding fossil fuel companies accountable, and in various other ways, research, etc. What's climate attribution science and why is it important?
Yeah, let me take that one. So there's basically three different parts to climate attribution, and the strongest attribution studies have all three parts. And the three parts are one, a clear physics connection. So, you know, why is climate change driving more extreme rain events? Well, we understand that. You know, the atmosphere has more water vapor. You know, we can make this physics argument without anything else, just like the pure physics tells us this should be happening. Then you need to have observations. You want to see observations that show changes kind of like what the physical argument says. And the third thing is you want to have climate models. So climate models take essentially all the physics we think is going on in the atmosphere, throws it into a computer and simulates the climate. If you can get all three of those things, if you have a good physical argument, if you have observations that's changing, and then the climate models reproduce it, you can be very confident that climate change is doing that. So for things like heat waves, intense rain events, those are things that climate, we are very certain climate change is making those worse. For other things like tornadoes, we don't have a good theory. We don't have a good physical theory. We don't have good observations. Models struggle to simulate very fine scale features like tornadoes. So we don't have a good feeling about it. And so you really need to look at these things case by case. But for the things that we're sure about, we're very sure.
Dr. Dessler, can you tell us what things are we sure about and what things are we not sure about? And you kind of listed some of them, like extreme heat versus tornadoes. But
sure. So any heat event is made worse by climate change. And, you know, people have done studies. It's usually about 5 degrees Fahrenheit. So if it's 110 where you are in North America, it would have been 105 without climate change. So that's kind of that's a sort of rule of thumb. Rain events. More intense rain events is one of the oldest predictions of climate science. It was predicted long before it was observed. And then we observed it and the models simulate it. So we were very certain that we're getting these intense rain events and then more time between rain events. So you get what people now are beginning to refer to as hydrologic whiplash. You're in a drought and then it rains a lot. And so you have drought, then you have flood, then you have drought, you have flood, really unpleasant way to go. Sea level rise, we're 100% certain sea level rise is being driven by humans. When you think about stuff like hurricanes, there's various aspects of hurricanes that we have sort of weak confidence humans are affecting. Things like intensity and rainfall, we're reasonably confident. Intensity, we're not quite as confident. It's really a case-by-case basis, but we are definitely pushing extremes in the climate system. Humans are doing that. There's really no doubt about that.
And Dr. Dessler, I was wondering if you could discuss Hurricane Harvey. It had a huge effect on Texans. I had family from Houston who came to stay with us for 2 weeks while people weathered like the storm. Obviously, we were lucky that there were early warning systems in place, which is not the case for everywhere. Um, there were quite a few attribution studies that came out like 5 years later, a few years after the hurricane, showing that to what extent climate change had an impact on it. I was wondering, could you discuss some of these studies? How much did climate change make Hurricane Harvey worse?
Yeah, so I think that there have been a bunch of studies. They all come up with slightly different numbers, but I would say probably about 25% of the rainfall was attributed to climate change, and that's kind of an average of all the studies. And so, in some places, Houston got 60 inches. I mean, that's almost 2 yards of rain. That's a lot of rain. And a quarter of that was due to climate change. So it would have been 45 inches. Now, 45 inches is still a lot of rain. So that still would have been a serious storm. But climate change made it much worse, and a lot more people flooded because of climate change than would have flooded without climate change. It still would have been a big storm. It still would have been a home run, but climate change put it in the upper deck.
And Josh, you've worked a lot in disaster management, whether it's helping counties and officials prepare for disasters or helping them recover economically and like with housing afterwards. And I know you had done some work you've done quite a lot of work in Texas, and I think after Hurricane Harvey as well in Houston. But I'm really curious, what are some changes you've seen in disasters in Texas? How much more extreme and costly have they become, and why?
Yeah, I mean, this is definitely a can of worms. So I'm going to open it a little bit and kind of talk about it, and then maybe close it, just because it's a very long discussion on just emergency preparedness. In every state and every county is a little bit different. So when we think about our emergency management, our disaster management, this is oftentimes things that happen behind the scenes. Because if you see your emergency manager or emergency management agency working, you're kind of like, it must be a crisis or there must be something going on. But they're there all the time. They're there on what we call blue sky days when we're not dealing with disaster. They're there on gray sky days when we are in the midst of a recovery, and so on and so forth. So if folks are very curious, I would take a look at what your county's doing, what your city's doing, your state level emergency management offices are up to for preparedness and mitigation. Emergency management is kind of categorized into about 4 phases. There's a lot of iterations of this, but essentially we're focused on preparedness, response, mitigation, and recovery efforts. And in the instances of what we see in Texas, and we've been fortunate to work with a bunch of subject matter experts and emergency managers from Texas throughout the 20 years of National Center for Disaster Preparedness. And one thing that has become apparent are these tipping points, or these types of events like Hurricane Harvey that challenge the frameworks, the preparedness plans that were in place, and kind of forces a momentum of change and a new iteration of emergency planning. So when Dr. Dessler was mentioning the just the extreme of the rainfall, we see that around the world where built infrastructure plus the social systems aren't necessarily structured in a way that can absorb that amount or that extreme of the magnitude. And so we see that with emergency plans too, where we kind of have an expectation, or we run scenarios and we have a specific hazard. We take rainfall. There's a plan in place for when that happens. But when we get surprised by these tipping points or these extreme events where no plan could justly and adequately respond to all those things, this is where we get those disaster events where we're going to see very different outcomes based on how prepared people were. But some of it's completely out of control of the individual. It could be, where they're situated in the city, what they have access to, the resources, social capital that would allow them to relocate. So it really becomes this really difficult equation between what social support and institutional support, emergency management, local government is doing in these blue sky days to better prepare for these kind of gray sky extreme weather events. So I think just to summarize the response to that question is, in Texas specifically, I think there's a lot of lessons learned. After every disaster, you take Hurricane Harvey, there's an after action report that emergency management have to create and then refine for the next time that a similar event were to occur. But we are in an all hazard landscape right now. So it's also, as much as they're worried about, flooding, they also have to be concerned about extreme heat. They have to be worried about all these other types of hazards too. So it's a very complex thing, but ideally, from these lessons, that you're better prepared as a community for the next disaster.
can you maybe discuss some of the infrastructure challenges you saw after Hurricane Harvey? Like, I know, for example, FEMA develops 100-year flood zones, right? Flooding maps. Harvey might have recalculated the equation there, where areas were flooding that were not in those flood maps. Can you like discuss some of these kind of infrastructure challenges, or even like, I don't know, the highway systems, the levees were built to withstand certain amounts of pressure, but how did Harvey kind of flip the script there?
Yeah, it really goes into that risk multiplier aspect of where you're seeing kind of what was planned for and what was literally in many senses built for to sustain, let's say this I think I'm blanking on the exact numbers you used, Dr. Dessler, but let's say 30 inches of rainfall, but then the additional 15 that are part of this climate multiplier, right? So if we're building infrastructure for the 30 and not the 45 inches or whatever it might be, then we're going to be in for these surprises in our built environment in response to these disasters and rainfall. So that is part of the problem, is that we're creating our disaster and preparedness plans on aging infrastructure, on older models. But going to your flood maps and your flood zones question as well, what is the evidence and the data that's informing these mitigation efforts, right? Are we relying on kind of the historical data sets that when you have kind of these extreme weather events that are kind of outside the expectation, these are things when we're thinking about how do we build resilient cities that we have to account for as well. So one of the things in our space that we're, of course, pretty keen on and really paying attention to, and I think you might have Andrew K joining one of the sessions today who can talk a little bit more, is just balancing what we know from historical data plus what we can do with climate projections, but also kind of the trade-off between those decision-making processes. So from the disaster preparedness side, the more rich data that we have to inform the decision that we can help with all levels of emergency management, the better. But even having this plethora of information doesn't necessarily always mean that there's going to be the funding, the resource, the programs, the policies in place to do what we kind of would need to do to better withstand some of these extreme weather events.
And that's, again, like a great point about how risk is a combination of the hazard. So what is the actual event, the exposure, how exposed people are to the event, and then also vulnerability, if you have like the resources to bounce back. Dr. Dessler, I'm also really curious about, what Josh was just saying about working with outdated data to deal with some of these kind of extreme weather issues. Could you tell us a little bit more about your experience with the Texas Center for Extreme Weather?
Right. So, the way outdated data get into the problem is that all the infrastructure that we have in our city, whether it's a sewer system, bridges, a lot of it was built in the 20th century. And when it was built, some engineer somewhere had a book about what's the conditions, this bridge, what's the maximum temperature this bridge is going to experience. And they had some table, and because you need to build a little bit of margin into it, but you don't want to over engineer it, 'cause that's expensive. So the engineer said, okay, we're going to add this many degrees to the hottest temperatures. Bridges expand and contract, if you don't know that. And if they expand too much, it damages the bridge. So they have to build that into it. Similarly, sewers can carry so much water. So what's the maximum 1 hour rain rate you're going to get, et cetera, et cetera. And so you build this infrastructure, and then we no longer live in the climate of the 20th century. Our climate is different. And so we get temperatures that these engineers didn't expect. And so now what's happening, this is not a Texas problem. This is a problem for the whole world. Not all of the infrastructure, but much of the infrastructure is no longer appropriate. And we're going to have to we're going to have to rebuild or fix or do whatever to all this infrastructure. So you see, building new freshwater infrastructure, building new stormwater infrastructure, the Ike Dike, all of this stuff. It's like, we really need to build this. And, in Texas, they don't like to talk about climate change, but they still recognize this stuff needs to get built for some reason. We're not sure what. It's a big problem.
So how much, I mean, that's a great question, right? Like when climate change is very political in Texas, and you can no longer develop climate action plans. They have to be called something else, like energy efficiency, or I don't know, like resilience, something like bullshit. How are agencies accounting for very clear climate impacts in these plans, or are they not, like in Texas?
Well, that's a good question. If you look at the Texas Water Development Board, for example, they put out a 50-year plan for water in Texas, and it doesn't mention climate change. The word climate change only appears in one place in the reference list of another article. So, these people that work in Texas state agencies, they know who signs their checks. And that's who they work for. They don't work for the citizens of Texas. They work for the people who sign their checks, the politicians. And the politicians in Texas don't want to acknowledge it. So they don't. Similarly with ERCOT. ERCOT never talks about climate change. And ERCOT is really they misinform a lot about renewable energy and fossil fuel energy. I mean, it's really bad. It's very bad here. It's the problem with I always like to talk about climate change. It's not a technical or scientific problem. It's a democracy problem. And in Texas, this is a democracy problem. You have one party that is really beholden to fossil fuel interests, and they're really not challenged at the ballot box. So they can basically do whatever they want. And they say this is a democracy problem. And for the people that say, what can I do? What kind of career can I do that makes a difference? It's get involved in the politics. That's really where we're losing the battle. We're winning it everywhere else.
Thank you for bringing up ERCOT. ERCOT, I'm not sure how many people are familiar with it, but Texas essentially has its own electric grid. There's three main grids in the US. There's like a eastern and a western grid, and Texas. And it has its own kind of like board of directors and people overseeing it and agencies that manage it, which is really quite crazy. ERCOT also has not always been the most popular during, in 2021, a lot of Texans lost power during the winter freeze, and actually quite a lot of people died as well. Can we discuss, and I know Josh, we've talked about this a bit in class, Andrew, I'm sure you have some kind of insights, and Melina as well, although we're coming up to Melina, but I have some very specific questions for Melina on farmers soon. But yeah, how has electricity stability, and we've also seen rising electricity prices both in Texas and throughout the country. I think there might be kind of an impulse to say that's because of renewable energy, and there's more renewable energy being transitioned to the grid. Is it that, or is it like physical infrastructure damages to the grid, whether it's power lines being disrupted from more extreme weather, etc.? Yeah, can you guys discuss ERCOT and the Texas electric grid? How has electricity stability and prices been impacted by climate change, etc.? It's an open forum, please.
Sure. Let me take a first stab at that. So we know that when temperatures go up, people have to run their air conditioner more. So we can see demand increasing because of climate change. So everybody's buying more electricity. Now, the way the ERCOT market works is at the wholesale price, at least, which ultimately we all pay through retail prices. As the demand goes up, the price goes up because ERCOT has to pull increasingly expensive generators into the generator stack to meet demand. So as the temperature goes up, we have to buy more power, and each unit of power costs more because they're pulling more expensive generators in. I actually just published a paper where we estimated that climate change is costing about $80 a person in the ERCOT market. So, for someone who's middle class or upper class, that's not a huge amount of money, but $80 a person per year is not a trivial amount of money. And for people at the bottom end of the economic ladder, that's, it's like, well, maybe I don't buy medicine this month, or, I'm not going to be able to pay tuition or something like that. Now I will add one other thing. I do know you have Doug Lewin on, I think, in a future panel, and he'll certainly talk more about this. But between 2023 and 2024, Texas added an enormous amount of solar energy, and we can see that greatly drove down the wholesale costs. So during the hottest times of the year, and so renewable energy is saving us money. But when you talk about the price of energy that retail people pay, it's not just the cost of generation, it's also the cost of transmission, distribution, and the cost of taxes and social programs. And that ends up being a lot of the difference and a lot of the reason why costs are going up in places like California, where they have a big transmission problem. Houston is going to have a big transmission problem after Beryl hit last summer. And so, I mean, these other problems are actually bigger than the generator problems. Everybody pays about the same price to generate power. It's really these other things that matter.
Definitely. Josh, I was wondering if you might, and that was a great answer, Dr. Dessler. Josh, could you speak more about like disaster, like the winter freeze in 2021? That was a big deal, and we've had like other instances where Texans have like completely lost power for extended periods of time, and Dallas, Fort Worth, and throughout the state. Can you talk about like maybe, you know, normally how do, and electric grids are huge players in like the climate conversation. I think a lot of mitigation strategy is basically electrify everything and then transition the electric grid from gas, oil, coal to solar, wind, you know, hydro, geothermal, nuclear, whatever, clean energy sources. How as grids become increasingly important, as more people get electric cars and electric stoves and electric water heaters, and we rely on grids more and more, how can we prepare for disasters, for another kind of 2021 winter freeze incident? What should ERCOT be doing?
Yeah, that's a tough question. And I think I will approach it from the disaster perspective, but I think you said the word right there. People are relying on it. And so in our space, that becomes an essential function, or what we would call a community lifeline. That in the case of a disaster, if that lifeline is disrupted, it's one of the first things that need to have like a recovery time objective of less than an hour. Anything beyond that, there's going to be this ripple effect of consequences, of course. So if you're talking about instances where you're not able to restabilize the electric grid or give people access to power again, beyond 24 hours, 48 hours, days, it just creates a much more intensified recovery or even response. So there's more things just from the exposure, the vulnerability of having something like electricity go down during a disaster. Now you have to think through, how are people going to communicate? How are people going to refrigerate food? You know, there's a long list of things that happen the longer it takes to restabilize that lifeline. So that is something I think is just worth consideration for this specific electric grid. In addition to how do we prepare it, you know, you run scenarios of, you know, if this power were to go down for X amount of days, what are those ripple effects, so that you're not learning what those ripple effects are in the action of responding, which is much tougher than it sounds, because, you know, there's so many unknowns as well, the longer you play that scenario out. I will say it is also an area of interesting innovation with how other cities and communities are thinking about their grids for disaster preparedness, for community lifelines. We're seeing much more interest in things like bi-directional vehicle charging, where there's more of a communication between electric vehicles and the grid should one need power or the other need power. Vehicle to vehicle type electrification opportunities as well, with that same type of purpose. Could I power a home with my car? Could I power another person's car with my car, or can the grid have more of a communication? So I think it is going to be an area of interesting conversation, but from the disaster perspective, specifically, it is one where we have to treat it like the essential function that it is and the critical lifeline it is, and as much as possible prepare it for any types of disruptions, and then prioritize it in the recovery time objectives.
Yeah, like what are some of the impacts if people don't have power? Like who suffers?
Yeah, I think that goes, you know, there's going to be those immediate impacts, and then, you know, people might get power restored at different times, but it gets into a lot of that social capital pieces where, you know, some people might be able to get out of town, find a place that does have power. Others might be stuck in a situation where they won't have restored power for days. And those will play out almost at the individual, the family, the household levels in very different ways, and what that means for them, you know, in the sense of kind of the dependency on the grid. So we have kind of our vital functions where we need food, energy, and water, but some of those other types of scenarios that play out where we think of more vulnerable populations in the sense of, does someone need, are you caring for an elderly person that might need to additional medical equipment that requires electricity? Do you have children in the house that might need something that is going to be, even, this sounds kind of trivial, but in disasters, giving a child access to like an iPad or a computer for a distraction or a way to cope with what's happening is just as essential. It becomes one of those essential functions too that of course requires electricity. So you see this play out in a very, as much of it is a kind of a macro level disruption, at the micro level you just see many different pathways stem from the destabilization of an essential function.
Real quick, I'll just jump in too, because I did some reporting after Beryl last year. And one thing that you might not think about is like if you're a farmer and you have to take care of animals, like there are some animals that like if it's 95 degrees out, like you actually like kind of need air conditioning too, right? You need to run fans in a barn for cows, like things like that. And if you're kind of out and your grid is like not coming back on for a little while, you're like, how am I gonna get to even go get gas or something like that, right? Like there's just this whole other set of challenges that I think like farmers and people in rural areas have to deal with. The other thing I want to say, which is like related to energy, but like just a little bit different, is when we talk about like ultimately climate solutions and electrification is like and I should say like switching to renewable energy is one of the things that like has gotten cheaper. Like we do know kind of how to do it and like implement it, and the politicization of that is so connected to like farm country when we think about, farmers putting things like solar and wind on their land and whether they're willing to do that. And I just think that's another really unfortunate element of the politicization that Dr. Dessler was talking about, because yeah, it's we see this and we see this reluctance that in areas that used to be like, yeah, this makes financial sense for me as a farmer. And there's plenty of reasons why you might not want to, but I just wanted to throw that in, that like there's this connection to like rural communities as well. Like I think when we talk about like grids and power, we think a lot about cities. But there's this rural element too.
That's an excellent point, Melina, and brings me to my next question. And, I had written about this when I was a journalist. We had to talk to farmers who were firsthand kind of impacted by climate change. They would say things like, the weather is not the weather, it's not behaving normally. Or, we had hail during this time and we never used to. And suddenly there's all of these insects affecting my apple crop when there didn't used to be. And farmers really are at the front lines of climate change, which is not, typically when we think about who some of the most vulnerable people are, it's not always farmers. But I'm curious, through your reporting, and you've interviewed many farmers both in Texas and throughout the US. How have farmers reported being affected by climate change, and how much has their crop production been affected?
Yeah. So my answer for this is like the least fun answer, which is like it depends, right? Like it depends so much on where you are, what the crop is, what kind of methods are you using, and also like what resources do you have access to try to mitigate. So thinking about some stories that I've done in Texas, I mean, thinking about that idea of extreme heat just being bumped up a bit more. I did a story on pumpkins, right? And pumpkin farmers having to deal with, oh my gosh, I don't think we're going to be able to get this crop up. Like I think I talked to someone outside Dallas who she grows blueberries. She added a pumpkin patch a few years ago, and the year that I reported, they ended up just buying pumpkins to sell, because at that point they were used to offering this kind of like fall, like fall festival type thing, and they couldn't get enough pumpkins to survive. Thank you, Zayna, for dropping that in the chat. So that's just like one example, but it is so different depending on what part of the country you're in. Are you in an area that has enough water or are you in an area where you're relying on groundwater? And we're seeing a lot of places, especially out west, dealing with groundwater issues. And I don't know, also, I feel like if anyone is in the chat and being like, you're using like words that I've never heard of, like what is groundwater? It's like water that's stored underground basically and pulled up by a well. So yeah, there's things like that. It does depend from year to year as well. And some of the impacts are like a little bit harder to track. I think, like I was saying, with extreme weather that we know really clearly is being worsened by climate change, it's really easy to be like, yeah, okay, I can connect the dots here. But there's things like seasonality for certain crops. Like if you look at the map, like the gardening map, like if you want to grow something in a garden of your own, like what kinds of things are most suitable for a certain area, that's changing over decades. So it's kind of hard to pin down like this year, like, okay, I can really like look at that clearly. Yeah, and then things like infrastructure, things like irrigation infrastructure for watering crops. Not everyone can afford that. And I did a story like Zayna, if you want to put that one into where um yeah, like you're 5 years ago, you're like, yeah, this makes no sense mathematically because irrigation is really expensive and I get enough rains, so why on earth would I buy that? And now you have people being like, actually, my hay is not gonna come up this year. There's like grasshoppers destroying it, there's like, yeah, maybe it actually makes sense to spend hundreds of thousands of dollars on irrigation infrastructure. So, and not everyone has access to that. And I think that's why when we talk about like which populations are most vulnerable, oftentimes, including in the farming world, it's like if you're a big agribusiness operation and you can afford expensive technology, maybe you have a dairy, you can air condition for your cows, like they'll be fine. But then if you're a smallholder farmer in a part of the world that's warming very rapidly and you're relying on your cows for subsistence farming, yeah, that's going to be a lot harder and you're going to see more of an impact. So that was a long answer, and I can go into specifics on any of it if you want me to.
No, that was an excellent answer. I'm also kind of curious, and you kind of touched on this too, but like with more, as Dr. Dessler was saying, more variable kind of rainfall patterns and maybe you have more kind of extreme drought and then extreme like flooding or extreme precipitation. How have farmers been adapting? Like, are their fields flooded? And also, like, do they see these changes as climate impacts, or is it just like the weather's being weird? We don't know what's going on. Like, what? I'm very curious to hear more.
Yeah, absolutely. Again, I think it's such a range of responses, and I want to emphasize that like my job is not to prejudge like whether somebody is seeing those impacts as climate change or not. Like my job is to just talk to you and like understand what's happening on the ground. And I do think it matters. Like even if you don't like actually one of the people I talked to for the barrel story, I think I did ask her a question about climate change and she was like, I don't believe in that, but thank you for asking. And like the way she said it was so polite. And, I sent her the article after and it did talk about climate change and she was like, yeah, call me anytime. So I think like there is a world in which we have those conversations and it's like, yeah, this was a really big impact on me. And also like, yeah, just not everyone is going to be on that level. That being said, farming is like by no means a monolith, and there's plenty of farmers who absolutely believe in climate change. They want to do something about it. You were asking about like droughts and floods. I mean, I've been to like plenty of places where people are like, yeah, I lost part of my crop to like hurricane rains, or like there was a this is not in Texas, but there was a like a co-op in Oneida Country in Wisconsin that they grow like an heirloom variety of corn, and they lost because they do it in such a different way than the industrial corn. They lost like most of their crop due to intense spring rains followed by drought in the summer. So, and yeah, people were really sad because they were like, this is part of our community, this is part of our culture, and yeah, it really was like for them, they were like, yeah, this is us seeing climate change impacting something that we care about a lot. So it is such a wide variety of experiences, and I think we just have to meet people where they're at.
Just gonna take an audience question quickly. We have some really excellent questions here. I think some of them might be better suited for our mitigation panel, which is happening next. But one question from Sammy Sussman. I'm curious about the role that local governments and local organizations can play, or how are they experiencing climate impacts? I don't know if you guys want to discuss, like obviously there's offices of emergency management. I think probably every organization is affected a little bit, but yeah, what are the major ones? Government agencies.
Well, Well, I'll just add very quickly, just about every big city in Texas has a climate resilience or heat officer or something like that. And I do think that as far as infrastructure in the city goes, they can control it if they can get money to do it. But you also see that the state is moving to handcuff cities from taking action. So, for example, Denton famously, as a couple of years ago, tried to ban fracking in the city, and the state passed a law saying you can't do that. And so I think that there are certainly cities can do a lot, but the state's commitment to fossil fuels is able to override that.
Definitely. And there's like lots of very complicated kind of levels of governance where it's like the Texas is getting some money from the federal government, which it then distributes down to cities. And it's like a very kind of complicated funding loop and interconnection. Josh, I don't know if you want to take that quickly, and then we have one more question. We'll switch to the mitigation panel.
Yeah, just really quickly on the disaster side too, is it does require a little bit of a like a cultural shift in the politics of what gets rewarded in terms of the disaster phases. So I think politicians are more incentivized to have a really good response to a disaster, that they're out there, with the first responders. They're getting kind of some of the credit for, hey, this response went really well. There's also a high risk if it doesn't go well. But we see a lot more of kind of their presence and incentives in the response phase, where I think one thing that we need to look at is what could be kind of incentivized on the preparedness, on the mitigation side. Although, I think they really reap more benefits from being visible in the response, despite what we really need as communities is more visibility in the preparedness and mitigation efforts.
Definitely. One last quick question for Melina, and then we'll wrap up. Melina, do you have a sense for which stories resonate the most with audiences? I'm curious if there are some stories that really break through in terms of reaching people.
Yeah, I do think that depends on like how you define reaching people, right? Like if you were to just look at the numbers of like page views or clicks, like fortunately or unfortunately, it is oftentimes those stories, like I said, about extreme weather that do most well in terms of climate stories. And I do think that's just because, an example from this year is like the wildfires in California. Like my coverage of that, like it did really well, right? Because that was something that, first of all, like so many people pitched in to help cover that because it was huge. I mean, so many people lost their homes. I think it really, those moments, like they hit people, they kind of like wake you up for a second, like, oh my God, wow, that's really intense. And so I think they do tend to garner more individual page views. That being said, part of why I do this job is for if you have one reader who reads a story and reaches out and says like thank you for this coverage, whether that's it could be across the board, but I save all those emails because I think that just if we can reach people and a story has a specific meaningful connection for someone. I did a story on Navajo sheep herding, and one of those stories had a non-binary source, and somebody reached out to me and said thank you for doing that story because I so rarely see non-binary people like centered in journalism coverage. And that didn't necessarily even have to do with the fact that the story was about climate, but I think we just need to do the kinds of stories that also are meaningful for one or two people in a really impactful way, in a really like activating way, because so much of the news I think these days is like focused on getting like numbers and less about like what is going to galvanize people, right? Like what's going to make people get up and look at how they can be engaged in the world around them. So yeah, that's my answer.
Well, thank you so much, guys. This was an excellent discussion. I learned a lot, and we're really honored that you took the time on this Memorial Day weekend to be here with us.